My work is really about light. It's all about understanding the phenomenology of light, primarily daylight, but also artificial light. And I became involved in working with light as a medium basically in the late 1960s when I was in school. And that basically led me into glass as a material to capture and manifest and sort of explore qualities of light and information, basically, that the content of light in the work that I did. So a lot of the work, I'm just start to show you a few projects which in the late 60s and 70s were really film projects that explored a phenomenon of light and how you might capture a phenomenon that you would see in nature, synthesize it, and establish it as something you would experience in an urban environment. How you sort of connect people, as Richard was saying, how you connect people to a very richness of urban life where nature exists around us, but we tend to not observe it or see it. So my work really goes very much in the direction of having people understand the richness of an urban context and what architecture can do to explore that, amplify it, and sort of sustain a different sense of our lives within an urban environment. As Martha was saying, I've also sort of parallel with this work that I do as an architect and previously sort of an artist. I do a lot of work for Corning Glass Works, which is a very large technical glass company, which you may be aware of. And I started working for them in the 1970s on a lot of photosensitive glasses that respond to different wavelengths of light. And I've continued to work with them today, and we're currently working on a lot of glasses, which I'll talk about later, but all of these glasses today, which are used for all of our cell phones and computers, extremely thin glasses, literally thinner glasses now that are much thinner than this piece of paper and are hundreds of times stronger than the glass we're familiar with. And they're currently glasses that you can roll up. The glass comes in a big roll, almost like fabric. So one of the big things we're working on today are means of transforming construction utilizing thin film glasses, which deals with weight and quantity of glass necessary to enclose buildings and the structure of thin film structures, all these different aspects of glass that you couldn't necessarily explore in conventional types of glasses. But I'll talk about that a little bit. But I'll introduce you to my own work and how it has basically, I guess, sort of morphed over the years from work done in the early 1970s. I'm just going to touch on one or two of these to give you a sense of where I come from conceptually. This is a project done about 10 years later for a family in California that had a very extensive art collection, and there's a small river on their property, and they had a bridge that would lead you over this small river, and then they commissioned me to do this bridge for them. And the idea here is that you cross out onto this glass platform, then you move along this glass platform to the other shore of the river. So that moment in time when you're crossing the river isn't necessarily just going from side to side, but extends your experience of that particular ecology or environment. So this glass platform is really suspended over the surface of the river. The idea is that the light comes down, hits the river, reflects back up. So the glass platform, which is translucent, carries with it the image of the water itself. So the idea here is how, and this is really sort of, I'll just show you one or two of these projects. This is sort of how I tried to move from doing work in the art world primarily, which is a very limited audience, to how you move out of that into the architectural world, which is where I originally studied. How do you build things permanently that can capture in a conceptual way sort of a richness of our environment? So the notion here is that you walk on this glass platform, you've basically extracted the surface of the water and made that the surface that you're walking on. And by just using slightly reflective panels of glass, they basically superimpose reflected images of the landscape around you. So the bridge actually sort of consolidates the landscape on the one hand, and that also sort of lifts this quality of the water below it. So it's a way of how do you create environments where all of a sudden you begin to understand these elements that are around you in a very different way, and you sort of build a new experience or a new environment. So other projects done about that same time, and this is perhaps a little more conventional, is a small project done for a client out in the Midwest. And this is the only desire on the client's part that he's built it. This is a chapel. It's sort of a small chapel that's part of a seminary. And the only desire he had was to maintain totally clear views of the nature outside. So you'd sit in the building, look out at this very beautiful landscape and the trees. He would have been happy with that. But I wanted to try to figure out a way to do more than just have a clear glass window, but how you would sort of animate the space. So you're looking through the window, and the window is about 12 meters tall. It's quite a tall window. There's single pieces of glass that run the full height. And then there are these panels of glass, which are roughly that dimension, that stiffen these vertical pieces. So you look out at nature beyond, and there's sort of this overlay of another layer of glass in front of it. And basically what happens is sunlight comes in, a portion of the light is reflected, a portion of the light is transmitted, and you end up with this idea that the light basically occupies the space. It comes in and sort of dominates and takes over the space. And what's happening here is that as you have clouds in the sky, basically that image is brought in and projected on the wall. So you actually see clouds moving or birds. And then when the trees have, like in summer and fall, when you see those leaves moving, that image is projected down in. So in a way, it's connected to film. It's a bit cinematic in that sense, that it's bringing abstracted qualities of nature into the space, and you observe them in a very different way than you would otherwise. And of course, the dynamic of daylight is you'd walk in here sometimes, and it might not be anything on the wall, or there might be just very subtle pieces of this, or all of a sudden the whole image appears or disappears. So there's this great sort of dynamic, and I think that that's fundamentally what interests me. There's a quality of animation that we lose, but we need to somehow reintroduce. And then secondarily is this concept, which is something you'll see in most all the work we do, is that the window is no longer a single piece of glass, but you've taken that idea of boundary condition between exterior environment and interior environment, you've expanded that boundary. So you have an interstitial zone that reinterprets the relationship between exterior environment and interior environment. It's no longer glass as a transparent material that's abstract. Basically, glass historically in the modernist movement has been an abstraction. There's no material. You are seamless with the outer environment. The outer environment, inner environment are seamlessly joined. And the glass as a material has no physical presence. So our work is really just the opposite. It's about how does the glass device or structure or material clearly define the differentiation between interior and exterior. Like there is a richness and differentiation. And this is something down in Washington, D.C., done about 10 years ago. But it's a very good example of something that we're trying to get a better understanding of and execute projects more in a more informed way. This is a building built for a large sort of law firm. And the architects had designed a atrium space which had a skylight that's about 20 meters long and about 3 meters wide. And the space itself is about 50 meters tall. So very narrow slot, very deep space in the building with offices looking into it. Obviously, those dimensions effectively mean you're going to get light from 11:30 to 12:30, like in the noontime, you get a little bit of light coming in and that's it. So this is a device or structure that we built, which is made out of glass. There's a centerpiece of glass that's relatively narrow at the bottom, and then it goes up to about 3 meters in diameter at the top. So it's a glass cone inside of a fabric structure. And what we're doing here is on the roof is a heliostat, obviously a tracking mirror. It's not so large, it's maybe, the mirror is maybe this big, not much bigger than maybe half of that window over there. The sun, it tracks the sun. Sunlight, it then hits the secondary mirror, and then the secondary mirror drops the light down inside the cylinder. So what's happening is the glass, it's a special glass that has a particular prismatic surface on it. So we're dropping the light down into the cylinder over roughly 40 meters. and the glass, the light is falling at about 2-degree angle as it comes down. So the light hits the glass and it's refracted out. So you're taking the light and you're constantly over that full dimension. You're bending the light and projecting it out. And you see the light on the glass itself. You see the light on the fabric that's around it, and then you see the light that's passed through it, and you see it again on the wall. And the principle here, and this is just something that I think we all need to learn more about, is that if you think of that as just one small window, it's basically just maybe 2/3 the size of that one window. That's all the light we have, but you're actually then using it to illuminate a huge space. And it's only an example of saying that we don't know how to use the light. There's so much intensity in sunlight that your eye tends to close, and it creates very high contrast and all of that. So we're not really using that sunlight very well. But if you have a way of distributing it and having the light fall on multiple surfaces, you all of a sudden the perception is that there's an enormous amount of light. So it's just a principle that we think is something we need to work on more aggressively. So anyway, those are a range of things. We do a lot of those types of projects because they're great and fun and sort of fun to explore them and do the development on them, and they let you look at different phenomena in a more experimental way. And then we do a lot of work on buildings all over the world. This is the Hearst Headquarters here in New York, which is down here on 8th Avenue. The original building was built in 1928. New building was done with Foster, and we do a lot of work with Foster. I worked on his very first building, the Hong Kong and Shanghai Bank, many years ago. But we were asked to take that. This is the historic building facade here. This is a section through the building. You're looking at the historic facade on 8th Avenue, and then the beginning of the new tower behind it is how you bring people in through that original entry up to the new lobby. So we worked on establishing these large skylights in the space, and then primarily designed this element here, which is made out of glass. It's a glass wall. It's 3 stories high, and the escalators come up through it. But it's linked to sort of the management, the cooling systems of the building. We take the rainwater off the roof, we bring it down, it's stored below this surface, and it's chilled. The chilled water is sort of brought up and then run over the surface. So chilled waters, very cold waters, run over that surface, and it creates a whole convection current in the space, and the humidity basically condenses on that cold water surface. So you're using water as a dehumidification system and cooling system in the lobby. So on one hand, it's a cooling system. Secondarily, you're taking all this daylight, and much like a periscope, you're taking this bright light, bringing it down and bouncing it out to the street. So when you're on the street, you look into the building. Instead of seeing a dark volume or dark lobby, it's a very bright surface, and it brings you in. So, and then I'll just conclude quickly with this last project, which is thinking about light in a very different way, where you're working, say, in the Middle East, where you have an enormous amount of light, of course, and then how you bring those light levels down to a reasonable level, both for the thermal performance of the building, certainly, but also just for your sensibility of your eye sort of adapting to it. So this is the reorganization and sort of redesign of the Israel Museum. It's in Jerusalem. This is this walkway, and then how that gets transformed into this. That's basically the new passageway, which is below ground. And this, you're standing here, you're actually almost 20 meters below ground. So you're, say, for us, 60 feet below ground. How do you make that feel day-lit? How do you get people that are that far below ground to feel like they're connected to the landscape and nature and the qualities of light? So we have these courtyards outside that bring in light, and they're all grown plant life, so you have a sense of greenery along here. And then there's a water element that runs along the whole walkway that allows sunlight to come through it and then animate that whole lower space. And that was that entry below ground. And then for the buildings themselves above ground, as I said, wanting to build buildings entirely out of just not even insulated glass, but just clear laminated glass. The buildings are all glass. We then framed them or housed them in these shading pavilions, and we developed 2 different configurations. One shading system for the east-west of the buildings, obviously where the You got the low angle of sunrise and low angle of sunset, where you get the most heat coming into the building. One elevation for those two exposures, and then a different shading system for the north-south, which can be much more open. But the principle here is with these extrusions, which I'll show you, these are ceramic extrusions, as the sunlight comes down, and then it's designed in such a way that it has a slight curve inside. So the light hits on the outside, and then the light bounces back, and then illuminates the inner surface. So the outer wall basically is taking, or actually sloped a little bit, taking the light and bouncing it back on itself. So when you're in the building, the whole, what you would think would be shadow or shaded, is actually all illuminated. These are the north-south elevation, which you can obviously see through. And that has sort of an unusual profile to it as well, which does the same thing. You sort of end up with this sort of quality of light. And the light is coming in because we have this water element overhead with light coming down. That's the diffused glass wall of the tunnel with these courtyards that are sort of intermittent. So that if you're down below, you can look up. Actually, the water's running over the surface, the sun comes through the water, so that whole space is sort of animated by qualities of light. Just in summary, so there's a big transformation which will probably take, you know, another 10 years to actually happen, because there's no industry out there that can actually deal with these thin glasses. So it's a way, it's trying to establish like what type of industry is that can handle these new glasses. It's totally different than the current industry, and how you begin to introduce that, and how that can contribute to, you know, both sort of power opportunities and daylighting opportunities, all these things that happen on buildings. So it's probably a little different than the other talks you've been hearing, but it might be of, might have been of interest anyway.